Hello everyone, welcome to AWS Tutorials. In AWS Tutorial, you'll learn about AWS services. Today, we are going to discuss about when you are writing a Glue job, how should you work with data sources? And it might look little confusing to you topic in the beginning, but let me explain you next couple of slides what problem I'm going to discuss and what is the recommended solution for that. And towards the end of the presentation, I'm also going to show you a small demo to just demonstrate whatever we discussed during the presentation. So let's get started. So when you are building a data lake, there could be various data sources. And these data sources are attached to your data lake. So your data could be in S3 bucket. Your data could be in Amazon Redshift if you have a warehouse kind of data. Or if you have a relational data, then your data could also be in some kind of relational database. And so some kind of JDBC data source. And all these data sources are registered with your data lake. And as a part of the best practice, once you register your data sources with data lake, you also catalog your data so that your data is searchable and discoverable. So generally, you will see this kind of data lake setup where you have a data lake with various data sources configured with it, and all the data sources are cataloged so that end users can use catalog to find the right data. Okay. Now here comes the challenge part. And the challenge part is not exact challenge part. It's more of a question of the best practice. So if I am writing a ETL job, should I use data source directly or should I use data catalog? What I mean by that, if like two examples over here, suppose you're writing a Glue ETL job, which is doing ETL job from a data in S3 bucket and moving it to Redshift, or another ETL job, which is taking data from Redshift and moving into another table in Redshift. And it could be any combination, guys. I'm just showing it as an example. It could be S3 to Redshift, Redshift to S3, Redshift to Redshift, S3 to S3, or RDS to S3, RDS to Redshift. No, all those combinations are possible. So the question is, if I'm writing this kind of ETL job, should I write an ETL job which simply talks to data source? Like I write a code which reads data from S3 and writes to Redshift? Or should I write a code which is actually reading data from catalog and then writing it to Redshift? So the question is that if I am writing an ETL job, say from S3 to Redshift, should I simply write a code to read data from S3 and write to Redshift? Or read data using Glue data catalog, and then write to Redshift? And same question arises for Redshift to Redshift as well. If I'm writing a Glue job from Redshift to Redshift, should I read from Redshift, write to Redshift, or read from catalog and write to Redshift? Technically, both are possible. You can read data from S3, you can read data from Glue catalog. You can read data from Redshift, you can read data from Glue catalog. So if both are technically possible, which way should you use? And that's the topic I want to discuss today. And let me give you a very quick solution, and then I will describe why we went for that kind of solution, and then also how to use that solution. But the recommendation is to use data catalog. Okay, so that was like there's no suspense there actually. Yeah. So the recommendation is that you should use data catalog. So whenever you're writing an ETL job, where you are like in the first example, you're writing from S3 to Redshift, you don't talk to S3 bucket directly. You talk to Glue catalog and then write to Redshift. And similarly, in the second example, you don't talk to Redshift cluster directly in your Glue job, but you talk with the Glue catalog and then write to Redshift. That's how you should be doing. That's a recommendation. And this is true. I will give you another example and then to show the whole, in fact, a flow of a pipeline. And this is true for that flow as well. So suppose you have this kind of pipeline where I have some my source data in a JDBC endpoint, and then I'm writing an ingestion glue job to move data to S3 bucket, and I'm saying this is my raw data. Then I'm writing a cleansing job to take my raw data and convert into a clean set of data. And then I have a kind of a curated glue job, which is taking this clean data and converting into a curated data. And in case of curated data, suppose in this example, I am now keeping my data into Redshift. Again, the same set of question arises. Shall I simply talk to data sources? Like, shall I simply talk to JDBC and move to S3, or S3 to S3, or S3 to Redshift? But again, no, that's and the same rules, same recommendations applies here as well. You should not be talking to data source directly, but you should talk to catalog. So you will catalog your JDBC endpoint and then use that catalog to move data to S3. Then whatever data you moved into S3, you catalog that data, and then use that catalog, glue catalog, to move data to clean state. Again, catalog your clean states, and then let your job use this glue data endpoint to write to curated stage in Redshift in this example, and then you catalog that as well. That is what. So this path is a recommended path, and it looks like additional work because you are cataloging and reading from catalog, but it's not. And a lot of this can be automated and configured, and at least it provides, in fact, more, I will say, more simplification and more harmonization into your job, into your pipeline. And I will discuss that in the coming slide. But that's how the recommended way is, that whether you're writing an individual glue job or you're writing an entire pipeline, if you are reading data, if you are sourcing data, don't talk to your data source directly, but talk to the data catalog. That's a recommendation. Now, in the rest of the slide, I'm going to discuss why we should be doing it and how we can do it. Okay. So moving forward, so why data catalog is recommended? Why? I mean, if technically you can talk to data source as well, why I'm saying you should talk to data catalog? And there are various reasons for that. The first reason is that your data catalog is the one place to find your data. Your users are the users of your data lake. They don't care and they don't want to worry about various data sources spread across. Your data could be in S3 to 10 different JDBC databases or 5 different Redshift cluster. They don't want to care about those specifications. They want to come to one place to find all your data irrespective of their data sources. And data catalog is that central place where you can find catalog of all of your data in the data lake irrespective where they are residing. Okay, that's so your catalog is a single place to find your data. That's why you should be talking to the catalog, because you come to catalog, you saw your data, and then you want to talk to it. So talk to the catalog. You don't worry about what data source is behind it. The second thing is, and this is a bigger region, in fact every region is valid here, but this is one of the, you can say, piping reason here, is that it helps you create a centralized access control. So for instance, you want to control in your catalog which data a particular user can access and which data or which not. That whole access control you can configure in data lake using Lake Formation. So you don't need to go to your individual data sources and say, okay, this Redshift cluster, this user can see following table and this the user cannot see, or go to RDS and control access there, or go to S3 and control access there. All those things are not required. You come to a single place in your data catalog use AWS Lake Formation to decide which catalog a user can access and which not. And through that, you can actually control access to all of your data in your data lake from a single central place. So just think of yourself having 50 data sources, managing access control in all these 50 data sources one by one, versus coming to a single place and controlling access to your data. Which one sounds more reasonable to you? So that's another reason why you should be using data catalog, because then this data catalog can be, their access control can be controlled, can be managed from a single place using Lake Formation, which simplifies your whole administration and management job. The third thing is, it simplifies your job code. Simple example, if I'm talking to S3, then I am using, say, if I'm using Python as a language, then I will use Boto3 Python library for that. If I'm talking to, say, for instance, a JDBC endpoint, then I will use, depending on the database engine, whether it's a Postgres or SQL Server or MySQL or Oracle, I have to use a Python library for that kind of database engine to write code against that, if I'm talking to data source directly. Similarly, if I'm talking to Redshift, I have to use Redshift data API, for instance, right? So depending on different data sources, if you're talking to data sources directly, you have different set of libraries to talk to different type of data sources. But if you are talking to data catalog, there is almost similar code, irrespective you are talking to a data sitting inside a S3 bucket, or sitting inside a JDBC endpoint, or sitting inside a Redshift. So you don't need to worry about 50 different packages and 50 different methods to program, to write your code. All you have to do is find a single method, single approach using, like I'm going to give example using PySpark in this case, to talk to each of these data sources. So that really simplifies your job code, irrespective of which data source you are talking to. So almost all code, whether you're talking to S3 or Redshift or JDBC, will look similar. So these are the three compelling reasons why I recommend that you should be using data catalog to talk to, not individual data sources. Okay. Now, since I talk about Lake Formation, I want to quickly touch upon that. So your data catalog access control can be managed using Lake Formation, and Lake Formation actually provides you really in-depth access control over your data. You can provide access to data to the users, to the groups, to the roles. So whether you want to give access to the end user, or you want to give access to the role, so that even jobs or crawlers, they use roles for authorization. So jobs and crawlers can also be given restricted roles, so that they can only work in the restricted area. And end users can also be given permission, to the specific data catalog. Now you can also provide different specific permission from the action point of view, whether you want to alter the catalog, or insert data, or drop the catalog, or delete data, or simply select data. Depending on what you want to do that, actually you can be given, a user or a group or role can be given a specific permission. You can provide column level security. Suppose you want to give select permission, but you don't want to give permission for the entire table. You want to give it for just 2 columns or 3 columns. You can do that column level security. You can also do row level security, which is not generally available at this point of time. It's still under preview, but if you have preview access, you might have seen this. But actually you can provide also row level security, where you say a user or role does not have access to the entire table, but only to specific rows in the table based on certain conditions. But yeah, row level security is still is declared by AWS. It is coming, but it is not generally available yet. So Lake Formation really provides a very mature and comprehensive access controllable data catalog. And if you're using Lake Formation to control access to your data, it really simplifies your job because you have first a rich set of features to enable access control to your data, and second, all this access control you have to do at a single place, irrespective whether you have 50 data sources or 100 data sources registered with your data lake. So I wanted to cover this point, why lake formation is important here. So now let's move on. So if I am trying to fetch my data from my data source, so I am writing a Glue ETL job, and I'm fetching my data from data source. The recommendation is that don't fetch data from the data source directly, but talk to the Glue catalog of the data source. And in this case, actually, I'm going to use PySpark as example, and I'll do demo as well. So you can write a PySpark code which can read data from the Glue catalog and load into a data frame. Okay, and load into a PySpark data frame. And then you can perform some kind of transformation on your data frame data to create a transform data, because ETL is all about extract, transform, and load. So you extract from your Glue data catalog, then you perform a transformation on your data depending on your business requirement. And finally, this transform data is written back to the data sources. So when you write back to data sources, actually you write back to data sources directly. You don't talk via catalog. You write back to data sources directly, but there are certain methods available which do a lot of, it simplifies your job, and when I show you code, you will find out. But yeah, you write back to your data sources directly. But as a best practice, when you write back your data, you don't stop there. You run a crawler or set of crawlers, and you catalog the data as well, so that if anyone wants to use that data for any kind of transformation or even reporting purposes, they can talk to the Glue catalog. So that's how the whole process works. You read from the catalog, then transform it, and then you write this transform data back to the data sources. And once you write back to data sources, as a best practice, you always run crawlers to catalog your data so that even your transform data becomes visible within your Glue catalog. Simple, right? So let's move on and understand how this whole thing works at the code level. So suppose I am working with S3 data in data lake. So I have got my data into data lake, and that data is cataloged. I want to write a Glue job to read the data into my data frame. So I write my code something like that. So I use my Glue context here in this case, and what I'm doing over here is that I'm saying, hey, Glue context, create my dynamic frame. So as you know that if you're using Glue libraries, it creates a dynamic frame, which is an extension of data frame. So you're saying, create my dynamic frame from the catalog. So not from the data source, but from the catalog. And here is my catalog database name, and here is my table name. So I don't need to know where is my S3 bucket, what is the location, what is the file name, object name, no, nothing. All I need to tell, this is my database name, this is my table name, fetch my data, and then using this code, you can read data from S3 using a catalog. Similarly, when you're writing data back to, in this case, you simply use Glue context, write dynamic frame from options, then you provide your data frame, which data frame you want to write, what is your connection type, and in this case I am writing back to S3, so my connection type is S3. What is my connection option, where you provide the path where you want to write data to S3, and then in which format you want to write data. So it also provides a way to transform your data. For instance, you want to write to a CSV format, JSON format, Parquet format, Avro, that's several formats. So that's how you write data back. So you can see here in this case, using the same Glue context, you can write a dynamic frame data back to an S3 location and also specify the format. So that's how you read and write to the S3 bucket. And I'm going to show a demo of this whole thing. So yeah, no worries. And I'll also provide a code sample so you can play yourself if you want to do a practice in your own environment. Now, moving on to the next example, that suppose my data is in Redshift. And that Redshift data is then cataloged into my data catalog. And I want to write a glue job to read this data from the data frame into my data frame. This is how my code looks. Same kind of code, similar kind of code. You say df, load my data frame, glue context, create dynamic frame from catalog. Nothing changes over there. Then this is my database name. This is my catalog. This is my catalog database name. This is my catalog table name. And in case you're working with any JDBC endpoint, you have to provide a sync bucket location, just a single location. You can use a S3 location as a sync bucket location, and you can mention that location like a single location for every such query, in fact. So you simply provide a temporary directory, a sync bucket location, because your glue is serverless and it needs sometimes some sync locations for using internal use for internal use of the query and or storing temporary values and those kind of things. So again, you can see here in this case, I don't need to worry about my Redshift cluster name, table, what is the login name, what is the password. I don't need to worry about any such thing. I can simply mention my catalog database name, catalog table name, and the sync location, and then I can simply read data from this Redshift database table using catalog. And writing back again looks very much similar here. In this case, you say, hey, glue context, write dynamic frame. In this case, you use method from JDBC connection. I don't know what's conf mean here, but you're saying here's my this is the data frame I want to write. And in order to connect to my Redshift cluster, this is the glue connection I'm going to use. So you know that when you, in glue, you can create connections to JDBC endpoints. And then again, you don't need to mention here any login name, password. You simply mention the glue connection name over here, and this glue job will simply use the configuration within glue connection to connect to the Redshift. Then you also provide what table you want to create. So what table you want to create when you're writing this data back to that Redshift cluster, and in what database this table will be created. And then again, you have to provide a temporary directory location or sync location whenever you're working with a JDBC endpoint. So again, in this example, you can see over here that I don't need to mention a lot here. I mean, like for instance, I'm simply reusing my glue connection in my glue, which would have been used by my glue crawler to catalog my Redshift clusters. I'm simply reusing one of my existing configuration. I simply provide the table name I want to create when I write this data frame data back to Redshift cluster. I provide my Redshift database name, and then I provide my S3 location name or sync location, and I can write data back to the Redshift cluster. And similarly, if I try to take example with any JDBC endpoint, and sorry for typo over here, I don't know, I'm making a lot of typo mistakes nowadays, but if you're using a JDBC endpoint, not JSBC endpoint, what exactly is that? Well, JDBC endpoint, your code again looks similar actually. So you can see here, my reading is again, it's the same way. I'm providing my sync location, then my catalog table name and catalog database name. So I really again don't need to know my JDBC endpoint, my login name, password, table. I really don't need that. All I need is with what name these tables in this JDBC endpoints are configured in my glue catalog. I just need that table name and that database name, and I can read data. And writing back is similar. So this is very much similar to Redshift, because talking to a JDBC endpoint is similar. Irrespective you are which kind of database you are. So whether you're using MySQL or SQL Server or anything else, the method is almost the same. So in this case, again, I'm using a glue connection. The glue connection which would have been used by glue crawler to to catalog this JDBC endpoint, simply use that one. Provide your JDBC table name. So with this name, the table will be created for this data, this DF data, data frame data, my database name, and my temporary location. Again, exactly like Redshift, because both Redshift and JDBC are Redshift is also JDBC endpoint actually. So all JDBC endpoints, irrespective of database engines, work in a similar way. So as you can see, 3 code snippets over here. So you can see for yourself that how simplified the whole reading and writing process is with the Glue catalog, because you really don't need to worry about information about your data sources. You can simply talk to Glue catalog and get your job done. So let's see the things in demo so that you can see for yourself how this whole code works. So let me jump back to my AWS account. So here is my AWS account where I have configured different data sources. I have cataloged them, and then I have some code snippet ready, which I'm going to run in front of you. So first thing first, here is my first data source, which is where I've got my 2 tables, sales and customers. And then I have created a temporary folder over here. So this customers and sales folder, in fact, has got 2 CSV files with some sample data. And then this is my temp folder over here, which I'm using as a sync location in this case. Then here is my Redshift database. And this Redshift database, I have got some sample data loaded over here. So I simply launched the cluster, and I told the cluster that create a sample data for me, and it created some 6-7 tables for me. I'm going to simply use the outer box sample data. Then here is my RDS database, where also I have simply created 2 tables, customers and employees. So these are my 3 data sources configured with my data lake, my S3 location, my Redshift cluster, and my RDS cluster. Then here is my data lake. So in this case, I have got a database, and this database is called actually DojoDB. Then if I come to my tables over here, you can see here that my tables are all configured. So you can see here these users, listing, event, these tables are coming from Redshift. Then if I go to little down, you can see here this customers and employees. These tables are coming from a PostgreSQL database, which I have configured. Like my PostgreSQL database is in RDS. And then I have got 2 customers and sales, which are in S3 locations over here, and both are CSV data formats. You can see that all the data in my data lake is fully cataloged over here. So I don't need to really worry about this configuration detail or Redshift configuration detail. I can come to a single place and I can talk to these catalog to fetch my data. Now, what I've done to catalog it, of course, I've created crawlers, and using the crawlers, I have simply cataloged it. So if we come over here, let me go to the crawlers over here first. So if I go to Glue console, these are 3 crawlers. So one is my RDS crawler, which was crawling my PostgreSQL tables. There are 2 tables over here. Redshift crawler has configured Redshift table. S3 crawler has configured S3 table. Then of course I have created some connections. You can see I have RDS connection, Redshift connection, and these connections I used with my crawler to connect to those databases. Yeah. So let's go to my, so I'm not writing a Glue job over here, but I have created a developer endpoint. I'm going to write my code into a SageMaker notebook using developer endpoint so that I can show you the code execution in an interactive way. So I have launched a developer endpoint, and then I have launched a notebook instance over here, and this notebook instance I'm going to use to show you the code execution. So here is my notebook instance, and I'm simply going to start my instance, my notebook code, my notebook in fact. So here is my code. Okay, so it is a PySpark notebook, and here is my code written. I'm going to run that one by one and show you how it works. So first thing first, I need to create a glue context, because you can see every method I'm using is using a glue context. So I'm importing my Spark context libraries, glue context libraries, and then I'm simply going to create a glue context. So let's run this code. This is going to take a couple of seconds, and it will start my Spark application and will also create a glue context, and that glue context I can use to then call the methods to read and write data. So while it is starting up, let's go to the next step over here. In next step, what I'm doing is that I'm going to use this glue context to read data. So yeah, here I got my glue context created. So next I'm going to simply read my data, and in this case from DojoDB, I'm going to read data from customers table. So if I go to my console, my customers table actually is a data in my S3 bucket in a DojoDB. I'm simply going to read data from there. So I'm going to read data from the S3 bucket, and I'm going to show how does the schema of the data look like. So let me run this. So if I run this, it's going to, so see, I'm not mentioning any S3 bucket location over here. I'm simply getting data from the catalog, and I'm going to show how the schema of the data look like. And you can see here it has loaded my data, and these are the fields and their data types in my data. So I'm going to perform very simple transformation just to show it. It's ETL, so I have done extraction now. Now I have to perform some transformation. So I'm simply providing a simple transformation. I'm saying that I don't need all these fields. I just need this contact first name and last name. In this case, I am simply applying a select filter over here to select fields filter over here to say, hey, give me just first name and last name. So if I run this, I get a data frame, which is simply first name and last name. And then I'm simply writing it back to S3. So if I see over here, I'm seeing glue context, write dynamic frame, and then this is the data frame I want to write. So this data frame with these two columns. My connection type is S3, and then I want to write my data in my Dojo database, create an output folder, and write my data over there. So if I come to my Dojo data set, in fact, in S3 bucket, I don't have any output folder over here. I have got only 3 folders: customers, sales, and temp. So I'm going to run this code over here, and then I want to keep my format CSV only. I'm not changing my format. So if I run this code, it should write data back to my S3 bucket in the location specified over here. Okay, so let's wait till it finishes the execution. Now it has written back my data. Now if I go to my Dojo data set over here and I refresh my folder, you can see it has created an output folder, and in that output folder, it has written my CSV file over here. Okay. So again, the best practice is that since you have written a transform data, ideally you should have a crawler configured which should run and catalog this transform data as well. Okay. But I'm not doing it here because my focus is more to show you how to read from catalog and write back as well. So now that was the S3 example. Now moving on to next one, which is where I'm reading data from a Redshift cluster in this case. So for instance, I'm saying is, hey, I want to read data from my DojoDB, and then this is my table name, dev public user. So if I go to my Lake Formation over here, and that was dev public users. Dev public users, if I go a little up, here we go, dev public users in DojoDB, this data is coming from Redshift. Fair enough. But again, I don't need to worry about any of such things. All I need to know, okay, it's a JDBC endpoint, so I need to provide a Redshift temporary directory over here, sync location. So I'm going to run this code, and this code is going to read data from that table in the Redshift using the catalog, and then present me back the schema. So now my data frame has been loaded, and you can see this is how the schema of the table look like in Redshift. So what I'm going to do is that, again, I'm going to perform a kind of a dummy transformation and say, hey, I'm only interested in username, first name, and last name, nothing more than that. So I simply run that code over here. And by the way, this code I'm providing in the link in a description box, so you can download that code and run for yourself. So I'm simply running this transformation. You can see now it had filtered down just to 3 columns: username, first name, and last name. Now I'm simply want to write it back, so I'm saying write dynamic frame using JDBC. And in this case, I'm mentioning the Redshift connection. So remember, in Glue catalog we had a Redshift connection thing. So I'm mentioning the Redshift connection name. So it's going to use fetch all the credential information and connection information from this connection configured in the Glue. Then I'm saying in dev database, simply create a user mini table. And this is my sync location. So it's going to take this data, this df data over here, and it's going to create a table user mini in dev database. So let me run this one. So if I run this, it should take a couple of seconds and it will write data back to the Redshift cluster. Yeah, okay, so it's still working. Yeah, hope sometime soon. So yeah, here it's working. And it's writing my data back to the Redshift cluster. So yeah, here we go. So it is done. It has written my data back to the Redshift cluster, and I can verify it. If I go to my Redshift, and in fact I should be able to refresh my objects over here, resources, and if I do that, I can see a user mini table now. And if I run this query, select star from user mini. Then I should also see a data user listed from the user mini. So it should be there any moment now. Yeah, here we go. Here's my data in user mini. Fair enough. So it's working. So that was Redshift example. And again, I want to show this examples, run it, because I want to show you that, hey, how simple or similar the code is, no matter what you are working with, S3 or Redshift or RDS. Or like JDBC endpoints. The third one is I'm using talking to a PostgreSQL database in this case. Again, since PostgreSQL database is a JDBC endpoint, end of day technically, so I'm going to use similar method I used for Redshift. So if I come to my catalog, it's called Postgres. Sorry, here's my catalog. You can see here that it is yeah, here we go, Postgres public employees, which is a PostgreSQL data source in my DojoDB. So if I go and run this code over here, it's going to read my data from my Postgres SQL Server table into a data frame and show the schema. So let me run this code. Hey, it was fast enough. So it has an employee table with just 3 columns: employee, number, last name, and first name. Again, I am doing a very simple transformation. I am interested only in first name and last name, for instance. So I simply run that. Okay, that transformation. So it gives me only first name and last name. And now I'm writing back to my JDBC endpoint, or in this case, PostgreSQL Server database. So I mentioned my catalog connection. Again, this is the this is the Glue connection which had been used by, in fact, Glue crawler to catalog the PostgreSQL database. Here is my database name, Postgres, and I'm saying simply create a employees mini table and write this data frame data into it. And here is my sync location. So let me run this one, and it should be writing my data back to my PostgreSQL database, yeah, soon enough, hopefully. So it's going to write this data back to the PostgreSQL server. It has completed it, and I can verify it. So if I go to my RDS instance, I have already connected to my database. If I run my query, select star from employees mini, it should show me the data. Yeah, okay, still running. Yeah, here we go. It shows me the data. So it's a dummy data. It's all there. I'm going to it shows this working for me. So, but it's not that you can read only from Redshift and write back to Redshift, or read from S3 write back to S3, or RDS to RDS. You can do mix also, because end of the day, once you load your data into data frame, this data frame you can write anywhere. You can read from S3, write to Redshift, or vice versa, or write to RDS and vice versa. So just to show you that just to give you completeness. This data which I read from the RDS or PostgreSQL Server database, and I written back to the database back. I'm now going to write the same data in S3 bucket this time, and my location is not RDS. This is typo. It should be RDS output. Okay, I could have given that name as well, but since I'm reading from RDS, I want to write to RDS output. So let me write this data, and what's going to eventually what this statement is doing, it's reading data from S3 from RDS, doing a transformation and writing to S3 back. So if I run this code, it should do write to S3 back, and I can verify that soon once it is over. So hopefully soon enough it will finish the execution and it will write data back to my S3 location, and yeah, it's done. So now if I go to my S3 bucket location and I refresh my page, I can see now an RDS output folder over here, and then if I click the RDS output, I can see the data. I can see the data written over here. Okay, I can see the data written over here. So that was the example how you can write data from one data source to another data source. End of day, when you read the data, it's loaded into a data frame, and this data frame you can write to any other data source as per your ETL requirement. So that was all for today, guys. This code is available in the description box below. So if you want to run this code in your own environment with your own set of data, you can configure your own data catalog, your own data lake and data catalog, and then run this code, practice this code to see how this whole execution work. So that was all for today, guys. Hope you liked the video, and if you like, please click on the like button and subscribe to my channel. And we always look forward to your feedback, whether it's for new content or making some corrections, or if you want to discuss some topic which I talked about and you have some follow-up questions or something you want to discuss or design with me, feel free to provide your feedback in the comment section. I will make sure that I respond to that to answer your query. So I look forward to your feedback, and I promise to come back again in a week's time with another such videos, such tutorials. In the meantime, please stay safe and have a nice day. Bye-bye.